Three-dimensional coordinate system. To locate a point in space, three numbers are required. We represent any point in space by an ordered triple, A, B, C, of real numbers. In order to represent points in space, we first choose a fixed point O, the origin, and three directed lines through O that are perpendicular to each other. The three lines are called the coordinate axes. They are labeled x-axis, y-axis, and z-axis, as you can see on the right-hand side. The x-axis, y-axis, and the z-axis. The three coordinate axes determine the three coordinate planes. The x-y plane contains the x and y axes. And we have, where the mouse is right now, x-y plane. The yz plane contains the y and z axes. Yz plane. And finally, the xz plane contains the x and z axes. And this is the xz plane, where the mouse is moving right now. The additional axis divides space into 8 regions called octants. To help visualize the first octant, look at the corner of a room in the diagram. You will see that the floor represents the xy plane and the walls represent the xz and the yz planes. We represent the point P by the ordered triple of real numbers A, B, C. We call A, B, and C the coordinates of P. A is the x-coordinate, B is the y-coordinate, and C is the z-coordinate. To locate the point A, B, C, we can start at the origin O and proceed as follows. First, move A units along the x-axis. So you can see we have moved A units along the x-axis with the mouse. Then move B units parallel to the y-axis. So now my mouse is moving B units parallel to the y-axis. And finally, move C units parallel to the z-axis. So I'm moving parallel to the z-axis, and that's my point P, where we have point P is A, B, C. Example 1. Plot the point in a three-dimensional coordinate system. We have 4, 6, 2. We will locate 4, 6 in the xy plane and mark it with a cross. Then plot a point 2 units up from this location parallel to the z-axis. Let's use a diagram to demonstrate this. So I will locate the point 4, 6, so 4 units in the x direction, 6 units in the y direction, and here is my point, the xy plane, and then I will move 2 units up from this point parallel to the z-axis, and that gives me my point 4, 6, 2. Try this question number 1. You need to find the coordinates of the point P. You can watch the previous example number 1 and use that to help you with this particular question. When you have finished, you can play this clip again. Here is the answer to try this question number 1. The coordinates of P are -2, 4, -5.
Now before we continue, please don't forget to like the video and subscribe to our channel. As a reminder, we offer private and group online math lessons on Zoom. The first session is always free. We cover all UAE National Curricula, American and British curriculums. We also have the best MSAT math test preparation course with a 50% discount for groups. So if you are interested in a free lesson, Click the link in the description below, and send us a message now. Okay, with that said, let's get back to our lesson.
Distance and midpoint formulas in space. The distance between points A, x1, y1, z1, and B, x2, y2, z2 is given by AB equals to square root of x2 minus x1 all squared plus y2 minus y1 all squared plus z2 minus z1 all squared. And the midpoint M of the segment AB is given by M equals x1 plus x2 divided by 2, y1 plus y2 divided by 2, and z1 plus z2 divided by 2. Example number 2. Jace Mountain lets people experience nature by ziplining from one platform to another over the scenic surroundings. Two platforms that are connected by a zip line are represented by the coordinates 10, 12, 50 and 70, 92, 30, where the coordinates are given in meters. Part A. Find the length of the zip line needed to connect the two platforms, and B. Find the coordinates of the midpoint of the two platforms. For part A, to find the length of the zip line needed to connect the two platforms, we are going to use the distance formula which was introduced to you earlier in the clip. In this particular question, we are also given the coordinates of the two platforms, 10, 12, 50 and 70, 92, 30. And they are our values for x1, y1 and z1 and x2, y2 and z2 respectively. So using my distance formula, I'm going to substitute the corresponding values. So x2 minus x1 would be 70 minus 10, and then I'll square the answer, plus 92 minus 12 squared plus 30 minus 50, then you would square it. This would give me an approximate answer of 101.98. So that tells me that the zip line needs to be about 102 meters long to connect the two towers. For part B, we have to find the coordinates of the midpoint of the two platforms. Earlier in the clip, you were shown how to work out the midpoint. x1, y1 and z1 would be 10, 12 and 50 as mentioned in the question, and x2, y2 and z2 would be 70, 92, 30, also given to us in the question. They are the coordinates of the two platforms. To work out the midpoint, we will substitute these values into this particular formula. x1 plus x2, which is 10, plus 70, then divide by 2. Then we would have 12 plus 92 divided by 2, and 50 plus 30 divided by 2. Or that's the same as 40, 52, 40. So therefore, the coordinates of the midpoint of the two platforms will be 40, 52, 40. Try this question number 2. Al-Wadi Mountain has two platforms that are connected by a zip line and are represented by the coordinates 6, 8, 20 and 20, 30, 10, where the coordinates are given in meters. Your task is to find the length of the zip line needed to connect the two platforms, and B, to find the coordinates of the midpoint of the two platforms. You can pause the clip now, and when you are ready, you can play this clip again. Here are the answers to try this question number 2. For part A, the zip line needs to be about 28 meters long to connect the two platforms. And B, The coordinates of the midpoint of the two platforms will be 13, 19, 15. If you need more help with this question, you can watch example number 2 again, and that should help you with this particular problem. Find the component form and magnitude of vector AB with initial point A, -4, -2, 1, and terminal point B, 3, 6, -6. Then find the unit vector in the direction of vector AB. Vector AB can be represented in the component form as such, where you see x2 minus x1, y2 minus y1, z2 minus z1. This equals to 3 minus -4, 6 minus -2, minus 6 minus 1, and this would simplify to 7, 8, -7. And this is how we've represented in the component form. Having worked out the component form, we are going to use this information and then find the magnitude of vector AB. The magnitude of vector AB is the square root of 7 squared plus 8 squared plus -7 squared. You can see where the numbers 7, 8 and -7 have come from if you have a closer look at the component form, and this is equivalent to 9 root 2. Having worked out the component form and the magnitude of vector AB, we will now find the unit vector u in the direction of vector AB. In order to do so, we will divide the vector AB in the component form by the magnitude of vector AB. So we have 7, 8, -7 divided by 9 root 2. And if we were to simplify this, it would equal to 7 root 2 over 18, 4 root 2 over 9, and -7 root 2 over 18. Try this question number 3. You have to find the component form and magnitude of vector AB with initial point A, -3, -1, 2, and terminal point B, 4, 7, -4. Then find the unit vector in the direction of vector AB. Try attempting this question, and when you have finished, you can play this clip again. Here is the answer to try this question number 3. I hope you have managed to get the correct answer. If you would like further help, you can watch example number 3 again, and that will give you and provide you with all the details that you need to get to the correct answer. Example 4. Find 2w minus z plus 3y if y equals 3, -6, 2, w equals -1, 4, -4, and z equals -2, 0, 5. To work out 2w minus z plus 3y, firstly we will substitute those vectors as 2 times -1, 4 minus 4, subtract -2, 0, 5, plus 3 times 3, -6, and 2. And using scalar multiplication, that gives us -2, 8, -8, plus 2, 0, -5, plus 9, -18, 6. And finally, using vector addition, this gives us 9, -10, -7. Try this question number 4. Please attempt this question. When you have answered this question, you can play this clip again. try this question number 4. I hope you've attempted this particular question. The answer to this question is 8, negative 24, 18. If you would like more help and guidance, you can watch example 4 again.